Okay, so we've set a little bit of stuff up here. What we've got is we've got the Speeduino board plugged into the Arduino now, so that's all back together. And what I've done is I've just set up on my prototyping board a couple of sensors. We've got a engine coolant temp sensor here and an intake air temp sensor here. All I've done is wired them just onto the board to make it easy to connect to. It might look a bit complicated or messy, but it literally is the easiest way to test the board at the moment. And all I've done is connect the pins and jumpered them. So we've connected up here. We've connected a common ground to both sensors, so that you should connect both grounds together. All the sensor grounds should go together and should be totally separate to power grounds, so that you're going to get no interference. And here, so I've wired them up, both grounds to here, and jumpered into the board, and then both inputs are jumpered into the board separately. And here we've got a ground pin and coolant and intake temp sensor going back to the board. What I've also done is plugged in some pipe, and if we blow down the pipe or suck, we'll get pressure or vacuum showing up. So we don't need to power the board up. As you can see, it's not powered up. It'll be powered via the USB connection for now, because those sensors don't take any current really. Okay, so let's plug the board back in and let's see what happens in Tuner Studio. Right. Right, so things seem to have settled down a little bit. Air temp and coolant temp seem to be a bit better, around about the same. The map's wrong, so what we need to do is we need to go and calibrate things. So let's go to Tools, Calibrate Pressure Sensor. Here's our map sensor. Well, we're not using the 4250, it didn't come with that, so that's why that's wrong. We're using the 6400, so click that. That's okay now. And we'll go back to Tools and calibrate the temp sensors. Well, the air temp sensor is a General Motors one, and it has its own set of values here already. The bias resistor is also put in at 2490 ohms. That's actually on the Speeduino board, so, and that's at the resistor value, it is actually on it, so that's okay. We'll write that to the controller. Okay, now that it's done that, we can do the coolant temp sensor. Well, it's not a General Motors one, so we'll select none. The bias resistor is still the same, because it uses the same resistor and the same on the Speeduino. So we'll put 2490 just like it was. Now, what you need to do, if you're using the standard sensor, which I assume most of you will be, I've already worked out the values. And at 0 degrees, the resistance is 6,000 ohms. 21 degrees, it's 2500. And at 100 degrees, It's 196 ohms. So we'll write that to control it. If using a different temp sensor, you're going to have to measure the resistance at 0. So put it in a glass of iced water. You're going to measure the resistance at 21 degrees, roughly 21 degrees. It doesn't really matter, just room temperature. You need an accurate thermometer though, and then measure the resistance. And then at 100 degrees, so in a pan of boiling water, measure the resistance, put it in, and it'll make its own curve. We'll write that to the controller as well. Wait for that to finish, and we should have some semblance of normality with the controllers. Here we are, 20 and 21 degrees and 100. Well, we're near sea level, so it should be around about 100. Just slightly less because we're slightly higher than sea level. Now I've attached a little pipe to the map sensor so we can test it works by just blowing down the pipe into the map sensor. And also creating a vacuum. So that works, the map sensor works, excellent. We are around about 20-21 degrees, so know that. So that's good, and they're both similar, which is always a good thing. Obviously I don't have a throttle position sensor connected up, so it doesn't know anything about that. But this is just to test the board. Let's grab hold of the coolant sensor, and that should rise in temperature with the warmth of my fingers. Yep, there it goes up. Excellent. Brilliant. Okay, so we need to do some settings. Engine constants. We'll do these now for when we connect it up to the car. So what are we in? CCs and CCs a minute. That sounds good to me. 1348 is the engine CC. Number of cylinders 4. Injector flow rate in CCs a minute. Well, I know the blue injectors on the Coilpack Micra 159 because I measured them. Okay, and we want an AFR of 14.7. Yes, so do that. Okay, that's set that up. Map 4-stroke cylinders. Yep. That's all good. Let's click burn. Close that. We'll do a power cycle in a minute. Don't think we need anything else for now. Just have a look through a few things. So it's already populated the VE table. These seem roughly okay. You can put what you want in here, you can change them. So if you're never going to go around the 500 RPM, which the Micra idles at 760 roundabout, we don't really need that. We could start at 600, say, and then move and change these accordingly. And likewise, if you're never going to take it to 7,000 RPM, you're only ever going to take it to 6.5, you might as well have that as your last RPM range, which gives you a more of a run of RPM here where you're actually going to use. Entirely up to you. We need the 0 to what the 10 to 100 kPa, 100 being wide open throttle basically. We're not boosted, so 100 is fine, so that's okay. Right, I don't think there's anything else we need to go through at the moment. What we need to do is get it connected up to the car and set it up properly. few things we've got to do on the car first. So, right, but that'll be in another video.